Hey everyone, it's time for another reaction video. The holiday season is upon us, so I wanted to gift you with a few extra reaction videos. I'm going to do one today and maybe a couple more over the next few weeks, just to give you something to enjoy over your various Thanksgiving celebrations and things of that nature. So today we are going to react to a video called The Impossible Problem of the Origin of Life. So this is on a channel called Creation Ministries International. So it's some bullshit Answers in Genesis style apologetics propaganda mill. It's got about 160,000 views. Came out early last year, so you know, decent chunk of views, but you know, obviously is just kind of a perfect video for me to react to, since it's going to be, I predict, something in between like kind of standard Ken Ham bullshit all the way up to like the James Tour script, some of the Discovery Institute stuff in the middle. So I do not anticipate anything particularly challenging to be coming out of this guy's mouth. His name is Don Batten. Had never heard of him before, but looks like a douchebag. And oh, one other quick announcement, since we're on the topic of Origin of Life deniers. My new Mr. Farina t-shirts are available, and there's also a mug. If you go to just below the description of every video, you'll see my little store there. So if you click on any of those products, and a shirt or whatever, and then click Explore at the top, you can see all of my stuff. So I got some new shirts in there. One on the darker shirts and one on the lighter shirts, and there's a mug as well. So if you are a fan of very particular content that I have made, that could be a good. It's a good just in time for the holidays. And while you're at it, take a look at all my other shirts. I have some other clever ones. I spent a little time once coming up with some ideas, like my, you know, the Schrodinger's cat one and stuff that I thought were really clever, and I really sell almost no shirts. But the holidays are here, so if you've got that kind of science-minded friend that likes a good science t-shirt, it's a great gift. So think about it. Maybe get one of those. Otherwise, yeah, we are reacting today on this, you know, abiogenesis stuff. It's going to be the same old script as always, I am sure. So let's go ahead and start reacting now.
Getting a protein is a bit like having the whole solar system full of blind people, each with a Rubik's Cube, and they all arrive at the solution at the same time.
No, it's not like that at all. That's the dumbest analogy I've ever heard in my entire life. This is all these assholes can do, but this says coming up, so we'll get to this.
That illustration is painting such a clear picture of the impossibility of this happening.
Modern science has revealed a world inside the simplest living cell, which doesn't add up for it being made in some sort of chemical soup.
All right, we're gonna get some, we've got another soup hater. James Tour doesn't like soup either, and this guy too. Not a big fan of soup, these guys.
The origin of life is a huge problem for those who insist that it's come about through purely natural processes. Don, you have a PhD in biology. You've had a career in experimental biology. You understand what it takes for life to exist. So why do you think many people today will claim that the origin of life is actually not a part of the evolution story?
Well, it's only recently that popularisers of evolution have actually tried to get rid of the origin of life out of their story.
I like popularizers of evolution, also known as biologists, right? Otherwise known as people who understand 9th grade level biology. No, nobody is trying to get rid of origin of life. I think what you mean is that children in school don't learn about that because it's a much more technical and complex topic. 14-year-olds are ready to understand modification, you know, descent with modification and natural selection. It's a fairly intuitive concept that children can understand. Abiogenesis is not simple. It's a much more complicated problem that requires, you know, undergraduate level understanding of chemistry, certainly and other topics. So nobody's ignoring it. There's thousands of people working on it, and we've learned a lot. And I bet you don't know anything about anything they've ever done.
I think the simple reason they want to do that is because modern science has revealed a world inside the simplest living cell which just doesn't add up for it being made in some sort of chemical soup by natural processes, by some chance process. And the question of the origin of life has become so difficult that they want to put it aside.
Yeah, again, nobody's putting anything aside. There are thousands of people who work in the field of origin of life research. I bet you don't know any of them, if I'm being honest. And one thing must be made perfectly clear. Whenever these assholes say simplest cell possible, they're talking about the simplest cell that is around today, which is the product of several billion years of evolution. Simplest cell around today does not equal simplest cell possible. That is a very critical error that they make.
That's what's happened. And so we're going to look at today why it's become such a problem and what the things are that are intractable, unsolvable. There are things which are just unsolvable for the idea of what they call chemical evolution, that chemicals became life. And so that's what we're going to look at that.
Okay, so first of all, can you tell me what's needed then for the origin of life?
Well, we've got to get the right building blocks for a start. So if you're going to make a banana cake, you need bananas and flour for a start. And what are the bananas and flour for a living thing? What are the ingredients that are necessary to even get started? Well, you need amino acids. They're very important because they're the building blocks of proteins, and life's made of proteins. For example, humans make possibly as many as 1 million different proteins, and they're what make our hair, our skin, our eyes, they hold our bones together, all sorts of things. And the enzymes.
Yeah, not 1 million. That's no. I don't know what the actual number is, but we don't make 1 million proteins. Probably like 100,000 or something. Probably a lot. But it's all notice how they always do this. Like, look at all the proteins that humans make. Humans. We're talking about abiogenesis. The moment you start talking about, humans, forget it. The moment you start talking about any multicellular life, honestly, the moment you start even trying to refer to eukaryotic unicellular life, that's how you know these people are full of shit. It has fucking nothing to do with abiogenesis. You're talking about the product of billions of years of evolution to produce something that is so unrecognizable from the first protocell that you even begin to reference those organisms proves that you're a fraud. Sorry.
Enzymes that you're making to digest the food you recently ate, they're types of proteins, and they're all built from amino acids. And you've got 20 different amino acids that make proteins, and they're strung together in specific order to make all the different sorts of proteins. So the order of them is very important, but you need the right amino acids to start with. And here's the problem. First problem for their story is that when you have a chemical soup to make amino acids, and you can make them, some of them that way at least, you get both right and left-handed forms.
Okay, so that's not... so he's implying that it's a problem to get amino acids. Prebiotic amino acid synthesis is so unbelievably trivial that amino acids form in outer space. There are amino acids form in outer space outside of, right, there's no like liquid solvent, liquid medium to make chemical reactions easier. It's so trivial to get amino acids that they form in space. And we get way more than the 20 canonical amino acids, right? The Murchison meteorite had 70 something amino acids on it. So all of the amino acids present in extant life and many, many, many more are trivial to get prebiotically. It's not even something to be talking about. Second of all, he's going to pretend that the 20 canonical amino acids present in extant life were all required for abiogenesis. They're not. That's something that James Tour also continues to not be able to understand with his little sidechain linkage straw man challenge. We did not need all 20 amino acids for abiogenesis. I think it was something like 10 that have been demonstrated to be critical. And then now he's going to talk about the chirality thing. So let's watch him humiliate himself with that.
And so that doesn't help make proteins, and we'll go into that further. But the next thing you need in this soup, you need sugars. And sugars, we know sucrose and fructose and glucose, but life has made a lot of different sugars. And one particularly important one is ribose. Ribose is the backbone of DNA and RNA. And ribose is unstable, so it's very difficult to actually make in some sort of chemical soup. So there's a problem. But
yeah, it's not really. There's a lot of pathways that have been elucidated to get sugars, in particular ribose. I did a whole video. James Tour thought he had a big gotcha where he misquoted and misrepresented Ram Krishnamurthy because he did some work looking at foremost producing ribose, which makes it less likely out of the possible pathways. But even Ram didn't discount it completely, and there are other pathways as well. So no, it's getting monosaccharides is not an issue. James Tour likes to pretend that getting biologically relevant polysaccharides is an issue because he goes, look at this is crazy. They can connect in all these complex ways. How do you get these the monomers all connecting in the same way, connectivity wise and everything? Enzymes. Enzymes came first. Then you got biologically relevant polysaccharides. So that's different from this. He's talking about ribose. We do need ribose. That is one of the ingredients. So he's correct that amino acids of some variety, probably 10 or so, are needed. And ribose is definitely needed. But he's just blindly asserting that it's so hard to get them. Amino acids are trivial to get. Ribose, less trivial, but not a mystery.
The other things we need are things like RNA and DNA, the building blocks of those, which are called nucleic acids. So
No, we do not need DNA. Life predates DNA. The first protocell was RNA-based. Life was exclusively RNA-based for some period of time until enzymes catalyzed the formation of DNA. And then it's a very interesting thought experiment to think about how the genetic information switched from RNA to DNA. That's an outstanding question that we can research. But it is we are extremely confident that RNA was the first molecule of genetic material. So this is another way you can tell when someone is full of shit. When they're talking about abiogenesis and they bring up DNA at all, in any capacity, they're idiots and frauds. Sorry.
4 different ones that go into DNA, and there's one different one that goes into RNA. So there's 4 in RNA as well, but one of them is different, called a uracil. And uracil is particularly difficult to make too. So that's another problem because it's unstable, like ribose is unstable.
Yeah, they're not unstable. I don't know what you're talking about. That doesn't mean anything.
Then you've got lipids, otherwise known as fats. And these are essential for membranes. So the thing that wraps up the cell and holds it together is made of lipids or fats.
I guarantee you this guy does not know the chemical composition of any of the lipids or fats. Or lipids is a broad term that encapsulates a lot of hydrophobic molecules. It's actually interesting. Just today, I'll probably put this out tomorrow. So if you're watching this tomorrow, today is Friday. I just put out my video on in the inorganic organometallic chemistry playlist on the Fischer-Tropsch synthesis. And it's very interesting because it's a way of industrially getting these long chain hydrocarbons. And it's actually been, we're now beginning to understand that this kind of organometallic catalysis probably played a role in the prebiotic synthesis of lipids. It's a way of these small molecules interacting with catalytic metal surfaces to get this elongation, just sort of 2 carbon units interacting with the metal, oxidatively adding to the metal atoms, and then growing the chain, and then reductive elimination allows it to come off. So this, catalytic metal surfaces are crucial here, and in particular with lipids, this is probably how we got these first lipids. He also does not know the different kinds of lipids that can go into forming a membrane of some kind. So a classic thing is to pretend. So today we have phospholipid, bilayers, a phospholipid bilayer, which is a fairly complex structure, but they didn't have to be that way. First of all, they didn't have to be phospholipids. They could be simple fatty acids, and it didn't have to be a bilayer. It could be a monolayer. So just like with everything else, just like RNA first and then it became DNA, all of these aspects, the very first life, the first protocell, did not have to have the precise features of extant cells. It didn't have to have a membrane exactly like the membranes of our cells. It didn't have to have the genetic material, DNA-based genetic material like our cells have. It didn't have to have all of these things, any of these things, right? It's a straw man. It's a straw man that is propagated by people who have no fucking idea what they're talking about. Like, this shit is decades old at this point. The people who work in this field have understood this for decades. So,
and you can't make a cell membrane or wall just out of fat, because if you've got a fatty layer like that, it just seals everything in or seals everything out. But you need a cell wall which is going to get things in and out. So that doesn't sort of make for a cell.
Yeah, a fatty acid monolayer could do that. It won't have complex channel proteins, right? It won't have we have very sophisticated proteins embedded in the cell membrane today in extant life that can right, you have sodium potassium ion channels, you have all this kind of stuff. It didn't have those because it was much more simple. But there are molecules that can diffuse directly through the cell membrane. Right? There's a lot of stuff that can happen. It was a much more rudimentary form of life. It was a rudimentary membrane and a rudimentary form of life. A protocell that was so unthinkably simple, even compared to early prokaryotic life, right? What we would regard as early prokaryotes that even mildly resemble extant bacteria. Already that was tremendously more complex than the first protocell.
So they're just the basic ingredients before you even get started, but a lot more is needed other than that.
And these are basic ingredients that are needed just in one simple cell, let alone all the cells of our body.
That's right.
What do you mean, let alone all the cells in your body? We're talking about fucking abiogenesis, not the construction of a complex multicellular organism. Yes, if a scientist was like, hey, there were molecules in the ocean and all of a sudden a human formed, now that would be fucking wild. That would be pretty crazy to explain, which ironically is the thing that you assholes believe. You believe that a god went poof and or took some dust or whatever the hell is in your book of myths. That's what you guys believe happened. So wow, what a dumb question from this woman. One cell, let alone all the cells in your body. Unicellular life, abiogenesis produced an individual protocell. So
right, every cell in the body needs those basic ingredients.
Yeah, that's a lot of ingredients already.
Well, we haven't even got started yet in what's needed.
So we've got the ingredients that we need, but is there a problem with getting them all together to do what they need to do?
Oh, indeed there is. One major problem is that the conditions that can make amino acids, so you get the right conditions to make amino acids, they're the wrong conditions to make sugars.
Why? Why are they the wrong condition to make sugars? What are you talking about? You have some water, you have some molecules in water. That's the soup that pisses you off so much. What are the conditions required to make amino acids? Run me through the proposed prebiotic conditions for the synthesis of amino acids, and then do the same thing for ribosomes, or for ribose. What are those? Why can't they coexist? Secondly, why do they have to coexist? You could have isolated pools where certain molecules are being synthesized versus others, and you have tides, right? So certain pools can be filled with certain building blocks, a different pool filled with other building blocks. You can get different molecules, and then they can mix later. What's the problem? Right? There's just so much that you haven't thought of or are willfully ignorant towards. And it's all being discussed in the field, you know?
So if you've got nitrogen present, for example, you need that for amino acids, but if you've got nitrogen present, the sugars won't form.
So how do they work together?
What do you mean if you have nitrogen present? What form of nitrogen? Are you talking about molecular nitrogen gas? Are you talking about ammonia? What are you saying? Nitrogen, elemental nitrogen, an individual nitrogen atom? Like, what are you saying? And why would it prevent ribose from forming? And I love the rehearsed, feigned exasperation from this woman who has no fucking idea what the hell this guy's talking about. It's so painfully, transparently rehearsed and meaningless. It's incredible.
Can't. So they do these experiments and get sugars on the one hand. So, I got sugars and amino acids. Yeah, but you can't get them in the same soup. So you can't get them together. So there's a problem. And also metallic ions are necessary for life, like things like magnesium and calcium, for example. Calcium is very important in bones in humans, but they're important in all living things, calcium and magnesium.
Are they? Yes, calcium is important for bones. Did the first protocell have bones? You dumb piece of shit. Are you pretending that the first unicellular organism that ever developed had bones? Does a protocell need calcium and magnesium? Does it really? And would it do the things, whatever the hell you're implying it would do to inhibit the formation of a cell? I mean, good God, who falls for this crap?
If you've got calcium magnesium present and you've got lipids form, the lipids react there and form soap scum. So you think about it when you wash in hard water with soap. Soap's just a salt of fat, and it forms a scum. And that's what happens when you've got lipids and these ions. So you can't get the things together that need to be together.
There's so much wrong with what you're saying. A salt of fat, it's fatty acids, right? And oh my God. So all of those metal ions exist in cells today, and it doesn't do the thing you're saying. So why would it do it then? I don't know.
To form the first life.
So this chemical soup is not going to be able to, it's going to have ingredients, but they're not going to work together the way that they need to.
That's right. To craft a soup which makes one thing can't make the other.
Yeah.
That's the problem. And so, and fats, for example, are high energy. I mean, people know that if you eat 1 gram of fat, you're getting 2.25 times as much energy as you get 1 gram of protein or 1 gram of carbohydrate. So fats are high energy, and they're a problem because high energy things are more unstable. So that's much harder to make them.
Why? More unstable, why? What do you... high energy meaning when they're metabolized, the amount of energy that can be directed towards other functions in the cell. How does that correlate with some kind of instability? What are you saying? Why is it unstable? Have you even attempted to imagine how biosynthesis of those molecules would go? Right? If they're so unstable, say something about the proposed mechanisms by which they form. Do you know what those are? I'm sure that you don't.
And then the biggest problem, I think, above all those things, is what's called chirality. You think, well, what on earth is that? That sounds like a big word. But chirality is like...
It doesn't sound like a big word to anybody who went through sophomore year organic chemistry. Did you? She said you have a PhD in biology, so...
Handedness. So if you hold your right hand up to the mirror, you'll see a left hand looking back at you.
Yes.
And that's chirality. And so three-dimensional chemicals, like most of the amino acids and sugars and things, come in right and left-handed forms. They're mirror images of one another. And life only is based on one form. With amino acids, it's a left-handed form, and with the sugars, it's a right-handed form. So if you've got a mixture of left and right-handed amino acids, you can never get a functional protein.
Because that's the mixture you'd have in a chemical soup?
That's right. A chemical soup would only produce left and right-handed forms. It won't produce the pure left-handed forms, which are needed for proteins, and it won't.
Okay, so much wrong with this, and too much to elucidate in a reaction video. But first of all, no, nature exhibits a bias towards left-handed amino acids. This is known on the Murchison meteorite. There was a prevalence of left-handed over right-handed. So nature seems to make them left-handed more. in general. Second of all, even if you did have a soup, I'll call it a soup like they want it to be called, that was totally racemic, meaning 50-50, L and R, there are plenty of mechanisms by which a solution can become enantioenriched, right? There are phase changes. These things can crystallize and then sublimate. So I've shown tons of papers in my James Tour content whereby you can have something that acts as a seed for crystallization, such that you get enantiopure or nearly enantiopure crystals, while the other enantiomer remains in the supernatant. And then if you're in kind of a pool, you can have evaporation, or something could get washed away, and then so the R's are gone, the L's are in the crystal, and then they melt again, and now it's enantioenriched or even enantiopure in that pool. That's one way. Another way is that they don't have to be homochiral in order for the polymer to be functional, and then they can become homochiral over time, right? There's just like there are 5 or 6 different iterations, each one within which enantioenrichment can occur. So yeah, like I said, they just form L more often already. Enantioenrichment can occur before they polymerize. Enantioenrichment can occur, or they can become homochiral after polymerization is already taking place. There can be selection that occurs once chemical evolution is taking place. Like there's so many available explanations, all of which are being examined. And Donna Blackman is one researcher that has done a lot of work in this area. I reference her work a lot when debunking James Tour, and this guy has no idea what he's talking about. So
I won't produce the pure right-handed sugars that are needed for polysaccharides, things like starch and glycogen and so on, and many other things that are made from sugars.
It's DNA.
Or ribose with the DNA and RNA, for example. So these, because they're three-dimensional, it's a huge problem because you can't get life out of this sort of soup where you've got a mixture of the two. So you can't get a functional protein. So these stories about, having sparks flying through things and forming these chemicals as if that's got something to do with the origin of life are quite misleading.
No, they're not. And you're talking about the Miller-Urey experiment, which all of you boners do every fucking time. You're like, 1950s Miller-Urey, and then nothing happened. It's been 70 years. It's been 70 years. Try to keep up with what's going on in the field. And by the way, the Miller-Urey experiment is relevant. All the way back in the 1950s, we showed that basic components, small molecules, and a spark, right, providing some kind of energy, produces amino acids. It produced all the canonical amino acids and more, and other relevant small biomolecules. So yeah, it definitely didn't solve the problem of abiogenesis. It created some of the building blocks for life. But to pretend that it's not relevant just makes you sound like an idiot. It made amino acids. The first thing you brought up was we need amino acids. Yeah, we do. And we showed in the 1950s how it's unbelievably trivial to get amino acids. So I don't know what you're talking about, man.
They're quite misleading because you don't get the right left-handed amino acids, you don't get the correct right-handed sugars and things out of those sort of experiments.
And they seem to be able to spin some of the stories about these processes in a way that sounds convincing.
Yeah, and so students reading the textbook and whatever, they think, oh, they've almost got life. It's just so far from the truth.
So tell me more about how you've never read a college-level biology or chemistry textbook. Abiogenesis has nothing to do with synthetic biology. Origin of life researchers are not trying to get life. They're not trying to form life. They're trying to figure out how life came about billions of years ago. So the moment you start down that thread, you tell me, number one, you have no fucking idea what origin of life researchers do, and number two, you have no fucking idea what any of these textbooks say, because they don't say that. that. They don't say, oh, we're trying to get to create life and we're almost there. That's not what they do. They're trying to figure out the pathways by which these molecules came to be and then polymerize and then come together to form a functional cell. So you've never read any of these textbooks. How the hell did you get a PhD? Is that a real one, or is it like Kent Hovind's PhD? That's a good question for another day. As usual, I didn't do any research prior. I don't know who this guy is or anything about him, but it's a good question.
It's sounding impossible. The probability of this actually being able to happen by chance. Is there a way to calculate that probability?
Well, I think we actually need to deal with something else which is even more important than what we've just talked about, and that is the information in living things. Because this is takes it to another level. So living things aren't just a mixture of bits like a cake. You can't just throw all these bits together. Oh, you got life. That's what they thought of Darwin's time. Life's pretty simple, just a ball of stuff.
Yeah, that's what he thought of the cell, didn't he?
Yeah. It was sort of a bit of protoplasm or something, and it seemed all very simple. But today we know that's not the case. And living things are chock-a-block full of information, an information encoding system. And here's the thing, you need both the encoding system, which is the nucleic acid bases. We might call them chemical letters on the DNA. There's 4 of them. You take 3 at a time, and that makes what they call a codon, and each codon specifies an amino acid, the 20 different amino acids. So in other words, for a protein of 100 amino acids, you would need 300 of the codons, 300 of the chemical letters, because there's 3 for each amino acid.
Yeah, each codon, you need the same number of codons. It's 3 bases per codon. As always, he's looking at transcription and translation as occurs in modern multicellular eukaryotic life and pretending that was required for abiogenesis because he's a fucking fraud. That didn't happen. There was no DNA. There was no decoding, right? There were no ribosomes. There was nothing like that. You had single-stranded RNA that acted as a template for its own replication, and then some RNA strands are ribozymes. They have some catalytic function. That doesn't mean that transcription and translation is occurring. It wasn't. You're an idiot. You're a fraud.
So the coding system is just amazing. And there's nothing about the code which chemistry could create it, because there's no chemical relationship between the code and the amino acid it codes for. It's like if you look at the letters in an English alphabet, A, B, C, D,
yep,
and look at A, you say, well, looking at the A doesn't tell you how you should say it. It's just it's an arbitrary association with the sound. You just learn it.
It's not arbitrary. It codes for a particular tRNA that has a particular amino acid attached to it. So forget the fact that this has fucking nothing to do with abiogenesis. You don't understand transcription and translation at a 9th grade level. How the fuck do you have a PhD in biology? You fraud.
You learn when you learn English. If you only ever saw Chinese, you wouldn't have a clue what A in English meant. And so with the coding system, there's nothing about the code which relates it to the chemistry of the amino acids. It's an arbitrary code. But it's not actually arbitrary. When you look at the codes, and people have studied this, it's an optimum code. So it's an optimum code to avoid errors in the reading system and in the production of the proteins. So, and this baffles people. How could how did any code arise by any natural process for a start without intelligence? And then how could it be optimized by chance?
How could it be optimized by chance? It's called fucking natural selection, you boner. You're looking at extant life that is the product of 3 billion years of evolution, and you're wondering how something is efficient? And also, it's not perfect. It makes there's errors all the time, right? During DNA replication, there are errors, and that's why we have enzymes that go through and check for errors and correct them. And those aren't perfect either. They don't catch all the errors. There's mutations happening in every cell of your body every second of every day, because nature's not perfect, even after 3 billion years of evolution. But yeah, all of this shit is a non-starter. everything he's talking about has nothing to do with abiogenesis. And then he's definitely doing this, where did the information come from? It's the fucking sequence of monomers. If we're going to have the real conversation about an RNA-based genome for a first protocell, it's RNA, and the code is for any RNA strand that has any functionality whatsoever. It has to do with the sequence of monomers. If monomers are going to polymerize, they're going to polymerize in some sequence. They're going to do so to form billions of different sequences. Some of those sequences will have some biological function by chance. That's it. It's not that fucking hard to understand.
So these are fundamental problems. And so we've got the code, but you've also got the information written with the code. So this is another level again.
Is this a bit...
It's not another level. That's it. That's the sequence of monomers is the information. There's no secret sauce. There's no spirit domain essence that is the information, the magic information. It's the sequence of monomers. That's the information. That's it.
Bit of that chicken and egg problem as well?
Well, yeah, I mean, there's no point having the code unless you're using it to write information, and you've got all these specifications written on the DNA based on the code. So if you look at a human, we've got 3,000 million chemical letters on our DNA coding for all the things that make us human. And that information, so how much information in the simplest thing that can live? Well, scientists have done work on, say, things like a mycoplasma microbe, and that's pretty simple in this compared to a human. And, well, it's got over 400 proteins or 400 genes, and they sort of chopped out some of the genes to see if we can get rid of some of them, and it still works. Well, you can't take out very much. And what they found in the end was that the simplest microbe that can live, you're talking about over 400 proteins.
Yeah, so they do this shit every time. So you're taking extant life, you're taking life that exists today and trying to take things away to see what the simplest form of life is. That's not how anything works. That's like going into Manhattan and going into any modern building and going, how many of these pillars can I demolish before the entire building falls down? Oh, I can only take away 2 pillars? I guess these 16 pillars is the minimum number of pillars to produce anything that could be adequately called a building or a shelter. Is that true? Or could we also just have a pile of sticks and call that a shelter? But there's no piles of sticks in Manhattan. Gee, maybe it's because we've evolved past that and we have more complex edifices that we use as shelter in places where we do things. Does that mean it's impossible to have a pile of sticks or a structure made out of sticks for one person to go in there and have a shelter? No, we could still do that. And that's probably the first building that ever existed was some sticks doing that. So they're always going to do this. The simplest extant life today is incomparably more complex than what the first protocell was, as evidenced by the fact that it did not have DNA. He's continuing to talk about DNA and a code and transcription and translation. It did not have that. It did not have a DNA-based genome that was being read by enzymes to get codons and anticodons and in a ribosome and tRNAs to build a protein. That's not how proteins were made in the first protocell. You had ribozymes. There was no transcription and translation. Some of the RNA strands were ribozymes. They had some catalytic function. You don't even need a long one. There are small molecules that have catalytic function, both nucleic acids and peptides. Dipeptides and tripeptides have catalytic function. You can have this situation where it's symbiotic. You have oligonucleotides and oligopeptides that are beginning to form. Those have catalytic function. There's a synergy there. You start to get larger molecules. It was a very complex thing, right? I don't blame people for not understanding systems chemistry and how once given the monomers and they begin to polymerize, how that became the first protocell. It's very difficult to understand. I would not call myself an expert on that. Far from it. Even the experts in the field, we don't have a command on it. We know quite a bit. We've produced ribozymes. We've produced autocatalytic sets. We've demonstrated self-replicating ribozymes that evolved by natural selection. We have seen that. We've been seeing that for 20 years. So we know, we definitely understand roughly what happened conceptually. We understand that self-replicating sets of molecules came about, and we know it's possible because we've seen it. We've made them and we've observed them self-replicating and evolving by natural selection to better to better utilize a pool of substrate, nutrient substrates. But certainly we don't know exactly what happened, and it's very hard to understand for the lay people like this woman and this guy who, despite his background, seems to have no fucking idea what he's talking about. The moment you start talking about DNA this, DNA that, codons, anything like that, you are either an idiot or a fraud. There's no other way to put it here.
So there's over 400 genes on the DNA. So not only have you got to get the genes on the DNA, but you've got to get the reading system, which can actually read the DNA, translate the information into proteins and make a cell. In fact,
you don't need any of those things at all.
You need all the paraphernalia to do that with the DNA at the same time for it to actually start making proteins. So it's no good just having the DNA code. You wouldn't be able to read it. It's no good having the reading system unless you've got all the DNA information there to read, to make more proteins, to make more cells and things. So the simplest living thing is phenomenally complex. And we're talking about some of the machinery inside this little tiny bacterium, which you need a microscope to see. There are machines that unwind the DNA. So it unwinds the DNA so it can be read, because the double helix has to be unwound. Mm-hmm. And so that it actually unwinds it, and then it reads the DNA, and there's machines that read the DNA, and there's other ones that's actually twisted back again, and the ones that copy it, and they run along the thing copying it and they're copying it to messenger RNA to make the information for making proteins.
Yeah, and the first protocell didn't have any of that shit. It didn't have DNA at all. You're talking about extant prokaryotic life that is the product of 3 billion years of evolution or more. You're dumb.
And there's just machinery, machine after machine after machine, all have to work together for life to exist. And what we've discovered inside living things just defies the idea that this sort of thing could come about by some sort of chemical soup idea.
I wonder if Darwin was alive today and he was seeing the things that we know now, whether he would still believe in his theories.
Well, good question, and I wrote an article about that.
Would Darwin, I mean, first of all, Darwin would be like, holy shit, DNA? What's that? He would be completely baffled by genetics. I mean, he would learn about it. He was smart. He would figure it out. I mean, he would learn about it just the way the rest of us learned about it. But yeah, this is, I mean, now we're veering into a slightly more comfortable evangelical territory of denying basic evolutionary biology. They just can't help themselves. Darwin this, Darwin that. Anytime they start to reference Darwin, they're just talking about the most rudimentary concepts in evolutionary biology that are so profoundly undeniable. We observe them on a daily basis. We observe Darwinism, Darwinian, descent with modification and natural selection every day. Anybody who denies it is as dumb as a flat earther pretending that gravity isn't real and shit like that. That's how dumb you are to deny that. And Darwin was really smart. He was a really smart dude. So if he was alive today, I think he could catch up. I think he could catch up with the field that he helped begin. So, yeah.
Would Darwin be a Darwinist today? He shouldn't be.
No, he wouldn't be a Darwinist because nobody is a Darwinist because it's the fucking 21st century. It's not 1860. Okay, we don't talk. It's like asking somebody who studies quantum mechanics if they're a Newtonist. It's a fucking dumb thing to say. Okay.
Because what we know, but he was driven by his desire to get rid of God. Because he's upset with God about the death of his daughter. And
This every time scientists hate God. They're just trying to disprove God, so they make up mean science things to go, I don't like you, God, but they're lying, and we know because we love God, and don't listen to anything that disproves God. By the way, most scientists believe in God. Believing in evolution doesn't preclude the existence of God. Like, give me a break, man. Every goddamn time.
so I think he'd still be a Darwinist in a sense, because many people today that study this stuff, they're Darwinists. Why are they? In the light of what we've been talking about. They shouldn't be, but they want to get rid of God, basically.
So if we come back to this idea of what's the probability of this, is how would can we put a number on it?
Well, life is so complex. Even that simplest bacterium is so complex, you couldn't actually calculate a probability of life forming. But we don't have to do that.
No, we don't have to calculate the probability of a bacterium forming by chance, because nature never did that, and that's not what abiogenesis proposes. You're dumb.
Actually, we can calculate, using some assumptions, the probability of a protein forming, given you've got the right ingredients, all the 20 amino acids, the left-handed ones, and without all the right-handed ones, because that sort of halves the probability. Because if you've got 40 instead of 20, I mean, you've got to select just the 20. That means you've got 40 to choose from instead of 20. So let's make it just 20.
Yeah.
Well, no, let's make it fewer than that, because we didn't have all 20 amino acids when life began. Many of them are the product of biosynthesis once life already began. You're pretending that if there were more, that it would somehow interfere. Why couldn't they just be incorporated into the protein that made it? Yeah, okay, get ready for some fucking mental gymnastics with numbers. This is probably the part where he's like, okay, check it out. There's 8 zillion guys in a line from here to Pluto, and each of them has a Rubik's Cube, and if they were all gonna solve it at the same time while farting, and all of them did it and then went yoo-hoo at exactly the same time, that still wouldn't even make one protein. Let's hear it, asshole.
To make it a bit easier. And then let's just take a small protein, like 150 amino acids long, and what would be the probability of getting those 150 amino acids in the correct order? So how do you calculate that? Well, 1 over 20 is choose the first one, choose the second one, 1 over 20, so multiply them together, and then you multiply that 150 times, 1 over 20 times 1 over 20 times 1 over 20, 150 times. So it's 1 in 10 to the power of 195 is the probability of it forming by chance. Wow. Right. And also we've assumed that these...
Okay, so just going to jump in here. Yeah, this is every time with this crap. So let's do a little thought experiment. You have a particular birthday, right? What are the odds that you have that birthday? 1 in 365. Same with everyone you know. Let's say you have a party with 10 people and you go, okay, everybody say your birthday. Wow, what are the odds that the 10 of us would have those 10 birthdays? It's 1 over 365 to the 10th power. It's 1 in a billion, bajillion, zillion, whatever. And yet there you are fucking sitting there with those birthdays, right? What are the odds? It's crazy. Everybody has to have a birthday. Every polypeptide has to have a particular sequence of monomers, right? If you put 150, if 150 amino acids polymerize, it has that sequence. That's what it is. Yes, there are many, many, many possible sequences of amino acids, and nature made billions and trillions and quadrillions of them, and some of them exhibit some function. And if they exhibit some function, it is not the case that that is the only sequence that will exhibit that function. There is tremendous variability at every single position. Every single residue in that sequence is variable. Every single amino acid, every single residue in that sequence could be most of the amino acids, and it would still work. Do you know how we know this? In life, in living organisms, there are different versions of the same protein that carry out the same function that are present in different species, right? Polymerase enzymes are not they're not the exact same sequence. They have different sequences in different species, and they still do what fucking polymerase does. You could take any protein take any residue and change it to most of the other residues, and you'd get the same function. There's really only a few critically conserved residues in the active site of like an enzyme or something like that, and that's if it's an enzyme or a receptor. If it's a structural protein, it doesn't even have that. So so this guy's basically just like, I me not know how protein work. That's basically what he's doing right now. What is protein? I don't know. How do you do it? That's what he's doing.
Amino acids can string together without an enzyme, which of course we don't have yet, and that won't happen. And that's another problem with the story. But so the probability of getting one small protein, just one, not 400, just one, is 1 in 10 to the power of 195. And can anybody imagine that number? No, that's just way beyond. In fact,
what I can't imagine is how anybody is dumb enough to fall for the dumb shit you said. That's what I can't imagine. If some amino acids polymerize, you get some sequence. Nature does it a lot. It makes a lot of different sequences, and then some shit does something, and it selects it. That's it.
In fact, they calculated that the universe has 10 to the power of 80 electrons. That's a number with 80 zeros. So this is a number with 195 zeros. And so there's a guy at MIT actually calculated, assuming the universe was as old as the Big Bang and all that sort of thing, and how big the universe was, and
which of course we know it's not. It's 6,000 years old, right, guys?
How many events could have happened in the universe in that time frame? Was every molecular vibration or something in that massive time? And how many events would that be? 10 to the power of 120 is the maximum number of events in the universe, given its evolutionary assumptions about its age and everything.
When you say events, just explain what you mean.
Well, that just means something can happen. Not necessarily a full experiment with all the amino acids and everything, but just a number of events, number of things that actually tick, tick, or whatever, Any
tick, tick. His definition of an event is tick, tick.
thing. 10 to the power of 120. So we've got 10 to the power of 195 for this one protein. In other words, it would never happen. So,
yeah, but all of those particular sequences didn't form. They didn't happen. That one did. Do you see the problem here? Right? It's kind of like saying if you roll 1 million dice, what are the odds that you would get that exact sequence? Oh my God, 1 in a blah, blah, blah. There's not enough time in the universe to get the blah, blah, blah. No, you fucking roll them and that's the one you got. Right? What are you not getting here?
Fred Hoyle was a British astronomer and mathematician, and he did a lot of thinking about the origin of life and the probability of the origin of life. He did a lot of calculations, and he used an analogy to try and help people understand the problem. And he said, getting a protein, just a simple protein, is a bit like having the whole solar system full of blind people, each with a Rubik's Cube, and they're all fiddling with it. They're all blind, they can't see what they're doing, and they're all fiddling with it, and they all arrive at the solution at the same time.
Do you like my analogy? Do you like it? Look how I'm smiling. Are you impressed by the fun analogy I just made? There's nothing about that makes any sense whatsoever. First of all, an individual amino acid joining the chain is not like solving a Rubik's Cube. That's fucking not right. They polymerize. Here's an amino acid, here's another amino acid. Wet, dry cycling, whatever mechanism by which it's happening, it just happens. It doesn't require intelligence like it does to solve a Rubik's Cube. Second of all, why the fuck would it be at the same time? They're not all just coming together and going in 1 minute, in 1 second. It's sequential. Here's an amino acid, then another one, then another one. It happens one at a time. So nothing about that analogy makes sense. The fact that you would even say it is hilarious, but this little smirk, like you've just presented her with this diamond, like, what do you think of that? Was that a pretty smart thing to say? Huh? Science illiterate moron lady, what do you think of that? Unbelievable.
And he said that's the probability. I'll give you some idea of the probability of getting a protein by natural processes.
One protein.
Yeah. So then he went on to say, because he didn't believe in God, so he said, oh, well, life must have come from outer space because it didn't happen on Earth. But then when he did these calculations, he came to the conclusion that life couldn't have formed anywhere in the universe.
Yeah, what calculations? First of all, how did he, like, there was no calculation done on Earth for whatever you're saying, but then how would he do additional calculations for other worlds that he doesn't know the conditions that are on? Like, nothing you're saying is true, first of all, nor does it make any sense. I'm sorry.
And he came to the conclusion it must have been intelligently designed. Oh, that's a bit radical.
Yep, that illustration is painting such a clear picture of the impossibility of this happening by
Yeah, if you're dumb enough to believe it.
chance.
Yeah, it's impossible. So that's what that calculation shows. Because we only talked about one protein,
Exactly.
not 400 and so on. If you start calculating for hundreds, it just becomes quite ridiculous.
So if life didn't come about by chance, how did it come about?
What?
Well, this is one of the most certain discoveries of modern science, is that life did not come about by chance. So how did it come about? It had to involve intelligent design. Information and information coding systems never arise from chemistry. They only arise from intelligence. And so what intelligence could be responsible for life? The intelligence that created life is far above our intelligence. No scientist could ever dream of creating even one functional protein, let alone life. I mean, scientists are very clever at discovering life.
Stop beating around the bush. Just say God, asshole. Just say God did it. That's what this whole preamble was. We don't understand it, how it could happen, because we're dumb, therefore God. That's the summary of all apologetics. Just say it.
Discovering what proteins do and their structure, and all this has been marvellous discoveries that have been done, but they could never, ever have from scratch, before actually studying it, dreamt of creating life or creating even a protein that functions. So...
Or even creating a protein that functions. We do protein synthesis all the time. It's absolutely trivial to synthesize proteins. You plug the sequence into a machine and it does it for you. It's very, very trivial to do that. So I don't know what you're talking about there. And again, synthetic biology has very little to do with origin of life research. So yeah, you don't even know what the scientists do in the field that you're criticizing.
We're talking about an intelligence far above all the brightest scientists in the world, far above their intelligence that created life.
And even to me, that seems so clear with the evidence and the picture that you've painted, but yet we still have many brilliant minds
trying to prove that it could happen by naturally. So
it seems strange.
Well, it's about getting rid of God. See, the only conclusion we can come to is this super intelligence. Who's that? Sounds awfully like God as revealed in the Bible, the creator God of the universe.
Yeah, not only does it have to be God, it has to be the God in the Bible. It couldn't possibly be any other God, you guys. It has to be the God from the Christian Bible. Okay? You are in the right religion, brainwashed people watching this. You're going to the right church. Keep giving money every week, right? Don't think about other gods. Don't think about one of the other thousands of gods that could be the true God, who will be very angry that you chose the wrong God. You chose the right one. Don't even worry about it.
Who is all-powerful, all-knowing, and whose intelligence would be far above us. And so that's an unpopular conclusion.
Why do you think it's so unpopular?
It's so unpopular that the overwhelming majority of the world believes it. What the fuck are you talking about?
Well, if God made us, he owns us, and we're responsible to him for our lives. That's what it's about.
And we don't want to be responsible.
We don't want to be responsible. There's nothing new about this. This goes back to Adam and Eve in the Garden of Eden. They basically they want to do their own thing.
So why the God of the Bible then?
Yeah, good question. I don't know of any other viable candidate.
I mean, have you ever learned about religion at all? Do you not know that there are and were many other religions with many other gods? can't possibly be one of those, right? Because that's not the religion that you got brainwashed with. So those are wrong, obviously.
What else do we know about that could be responsible? There's only the Creator God of the Bible, and the Bible reveals God as one who made us in His image, and that humans, not anything else. So why did He make us in His image? Because He wanted to love us and us to have a relationship with Him, not that He.
Okay, so that last bit is He created us in his image because He wanted to love us, so He can't love things that don't look like Him. That's very dumb, but it's also nowhere near as dumb as the idea that there was an entity with arms and legs and a mouth and eyes and ears and a dick that was floating around in nothingness. Why, like, the idea that the features that a human possesses make any sense other than the evolutionary context with which we possess them to thrive on this earth, where we use eyes to see light and we use legs to walk around on the ground. If there's no ground yet, why the fuck would He have legs? If there's no light yet, why the fuck would He have eyes? Why would a God have all of the parts that we have when he has nothing to use them for? Like, you gotta be really fucking dumb. I'm sorry. You gotta be real. Like, to believe in a God as a nebulous, ethereal entity of some kind, that's different. I wouldn't call that dumb. I don't believe in it, but it's not, like, that's different than this. Like, you literally believe in a guy with a beard in the sky who made the sky and the earth and everything, but somehow looked that way before making all of it. You have to be so fucking dumb to believe that. I'm sorry.
He needs us, but that He wanted to love us. So He created us in His image for a relationship with Him. So that's why we exist, for a relationship with God. And the whole Bible is about God reaching out to us for that relationship, to love us. And He provided a way that we can actually know Him and have fellowship with Him.
Yeah, that's all it is. The Bible is just only exclusively about Him creating us and trying to love us. He totally didn't murder all of us a bunch of times. He totally didn't punish all of us and murder us and genocide us and then send us to hell for doing things that He created us to do, knowing that we would do them. He's just such a super nice, loving guy. What is your fucking problem, scientists? Why are you always trying to be like, no, God's not real? He's just trying to love us. And he wrote this book where He's just loving us the whole time. Why can't you believe it? God.
So there's a bit of I hear a bit of a call to respond there. How could we respond to that?
Well, the Bible says if we seek God with all our heart, we'll find Him. And so I encourage people to seek God.
Yeah, if you desperately want to believe that something exists, you'll trick yourself into believing that it exists. Yeah.
And you'll find Him.
Thank you so much for this amazing journey that you've taken us on.
A journey? 20 minutes of him vomiting the shittiest apologetics I've ever heard is a journey to you? Take a fucking hike. Go, like, hike up a small hill. That's more of a journey than what just happened.
You've written several articles about this as well, Don. Where would we find those?
Well, creation.com, there's a major article called Origin of Life. Quite simple. It's quite a long article, but it's explained in terms that most people can understand.
It's a major article that just summarizes all the dumb, wrong shit you just said. My God, I can't fucking wait to go read that.
And we've got lots of other articles at more technical level, but the Origin of Life one is comprehensive.
No, you do not have anything on a technical level. You do not understand 9th grade level biology.
And the things we've just been talking about, you can read about them there.
Thanks so much, Don. That's been incredibly helpful.
Thanks, Jess.
Yeah, yeah, that's pretty much what I expected. Yeah, that was, yeah, it's funny, like, you know, after doing the James Tour stuff, like, there's just nothing that an asshole like this can say. Like, James Tour, as dumb as he is, he has the most sophisticated version of apologetics surrounding Origin of Life, because he can obfuscate, he can use chemical terminology, much, you know, concepts and terminology much better than than a clown like that. But it's just like guys like this after doing all the tour stuff, like, it's just I think that's why I did this as a reaction video. I was like, there's nothing this guy's gonna say that isn't going to make me laugh my ass off the moment he says it. Yeah, so that was I don't know. Yeah, that was it. That's exactly what I expected. And so I'm going to try to do a couple more of these. I think I'm going to do one next week. I'd like to release one on Black Friday, and I'd like for it to be a long one. I think that the CPMs are really high on Black Friday because everybody's trying to get you to buy shit. And so I'll make more money if I have a really, really long reaction video on Black Friday. So I think that I'm going to do that, try to make some money that day. And but I don't know what to do. I have one other reaction video queued up, but it's another kind of short one like this. So go ahead and if you made it all the way through this, drop a comment. Let me know what you would like me to react to. That's pretty long. And by pretty long, I mean like 90 minutes or an hour even. An hour to 90 minutes, something in that ballpark. Somebody suggested I do another Jubilee thing. Maybe I'll do that. I'm not really sure which one. Maybe there's another... I don't know what else to react to. So yeah, give me some suggestions. I'm going to do that one probably next week. And maybe, one or two more, maybe before the holiday, before Christmas. Just to kind of, keep things fun. Keep things fun and festive. It's the festive season. My kids, my kid is, one of them especially, is obsessed with Christmas. He's just like, when can we get the tree? When can we decorate the house? I was like, okay, just, a couple of things here. Let's do it. I'm trying to hold out. I don't I don't understand. Like after Thanksgiving, you put up the tree. Am I wrong about that? It's got like one holiday at a time. That's how I feel. The day after Thanksgiving, fine, let's go get the tree. But yeah, anyway, I don't know. I hope everybody's having a great start of the holidays are upon us and everything. Hope everyone's happy, healthy, and thanks for watching. I'll see you next time.